Okay, well, welcome everybody to the second intermediate data science workshop. I wanted to start with just demonstrating the new website that I put together. Number one, I used Hostinger, Hostinger, to really consolidate two older websites on Wix into one new one. I have to say that to my surprise, it was easier than Wix and far cheaper. I have not found one negative aspect to it. I'm continuing to add content. I thought that I would start, we talked about having a little bit about AI every week. So there is the AI Tools Hub. I like the image of the wrench with the brain. So these are some of the same that I sent you all. There is that mega site Open Tools that hopefully you all have taken a look at. It's so big. So let me stop for a minute as Ida joins us.
Dr. Hoyt, I have a question.
Yeah,
So, what is the platform you use to make this website?
the host is Hostinger,
Hosting.
Hostinger. I will tell you, for hosting for 4 years was $150.
Ah, okay.
That
Okay,
is the
that's nice.
cheapest I've ever seen.
Okay.
And it's as modern as Wix. And this website was largely designed with AI, I might add.
Oh, okay.
So
Yeah.
it's AI is embedded. So I really do recommend it highly. I knew about it, but didn't realize they were as good as this, and the support is also good.
Ah,
So the whole idea here is I want this to be all encompassing, which is a lofty ideal, meaning I want it to cover all aspects of data science, but also AI.
mm,
So what I was going to show you is, we talked about AI tools. I wanted to just say what's out there, what I think is valuable, what isn't. I have not had a chance to look at all the tools on Open Tools. There are too many, really.
but I
Here's
tried some of them you have sent like last time. So, like, especially for like presentations, and like, I find it like really useful.
Yeah, I mean, I think you have to pick through it to find a winner. In other words, there's a
Yes.
lot of them, you wouldn't want to use or too expensive or still in beta or whatever. But,
Mm.
and again, and Philip, Dr. Haddad just joined. I'm just
Hi.
demonstrating a new website that I put together. And what I was saying is, I was surprised when I took website from Wix, shut that down and transferred not the content, but the domain to this website hosted by Hostinger. It was far less expensive and probably more intuitive yet than Wix. And Wix used to be the most intuitive website. So this is Hostinger, Hostinger,
Mhm.
and it really was a winner. I told it what I wanted, and it created most of the pages. I've added a lot of stuff up here, as you can see. So I just was waiting till people can come on. I think Carissa is going to join us a little late. But so I took the AI tools PDF and simply cut it and pasted it in here as an example. Now, the ones that I've added, and let me comment here. Are you all familiar with Napkin AI?
Yes.
Okay. Anybody not familiar with it?
I'm not familiar with it.
Okay. It's a winner and it's free right now. So what you do, here it is. I wanted to get a diagram on the four kinds of analytics. So I basically pasted this in, and then it gave me like 20 different combinations. And I just picked the one I like. So you could do different colors, multiple different presentations, but it adds an additional layer to what you would normally do with PowerPoint. Okay. So again, I think it's a real winner, if you will. I strongly recommend it.
And what is it called?
Napkin AI. And I think
Napkin.
it's because, in other words, in the old days, you might draw an idea on a napkin. I
Yeah.
think that's the idea behind it.
Okay.
That's my guess. The next one, data wrapper, is if you have a blog or website and you want to try to put a table or something interactive in that blog, good luck. Generally, that won't work. But data wrapper allows you to create these nice visualizations, which you then can embed on a website or blog or whatever. So that's a nice one. Presentation AI, I was impressed. I created one, but I thought that it was really worth looking at, to check out for sure. Some of the others are limited. They may only allow you to create a few slides on a free basis. I have a little trouble recommending some of these, I might add. Canva, I'm sure most of you all have already looked at. So that's a that you can create every kind of visualization, chart, infographics, you name it on Canva. I want to get down to another one, SketchWow, I've used, and let me give you an example. Let me find one there we go. Notice this diagram, whatever you want to call it over here, which is a sketch. This was created by them, also very easy. You can just tell the AI bot what you want and it creates it. And it can create it in all kinds of different motifs. This one, I forgot what they call it. It's just a simple diagram, but it breaks up the monotony of a web page. So I've got that. I decided to add it to several pages. So workshop, the textbooks that are available are here, linked to the different ones. AI analytics is interesting because I'm not sure exactly what I'm going to do. Here's going to be a web page on just generative AI and data analytics. Now I've started, and you can just click on this. At least it should. Well, let's try this one on Visly. Maybe the link is not hot. But here again, Visly is the one next week that we're going to go over that I think is the best of the breed. And this video, by the way, this was created, if you've got a second, I think we do. This was created with Visla, V-I-S-L-A. All I did is give it that same features.
Cutting-edge AI-enabled data analytics program designed to revolutionize how you manage data. Data challenges are a thing of the past with Visly. Imagine effortlessly analyzing data and generating insightful visualizations. Choose from 4 advanced LLMs, including GPT-4 and Claude 3 Opus, to power your insights, whether you prefer Python or R.
So that, again, was just taking these features in Visla, V-I-S-L-A, pasting them in there and not saying anything else. And that's the video it created. I think it was, as I remember, 4 minutes. So really dynamite, in my opinion. So next week, we're going to basically, number one, talk about Google Colab, which is a programming notebook, just so y'all understand how to use it. But we'll talk about AI and data analytics with 2 different approaches. One is Visly, and the other one is Gemini embedded on Google Sheets. So I will probably have another one up here on, I'm guessing, on generative AI, specifically cutting edge. If we have time, I'll show you some of the projects I'm involved with in testing the new reasoning large language models like DeepSeek. I'm really impressed how good it is. I think that it's really 2 steps above, say, GPT-4o. It's really impressive. So anyway, any questions about the website? I thought I'd share that because number one, I hope that's going to be very valuable to people. And number two, I was amazed how good the host is, how easy this was to create. If not, we'll get back to the subject matter. Let me look at my notes here. So what we want to do is we're going to talk about computer vision or AI analytics. And I think with that, I'll go down and go to chapter 10, part of it, and talk about this a little bit. I don't expect you all to have to know convolutional neural networks in tremendous detail, but I think you ought to have the big picture. And I'm going to go back and forth. The big picture is this right here. Convolutional neural network in all odds trained on something like ImageNet, which has 14 million images. So even though it did not train specifically on cars, it can, interesting enough, figure out what a car is based on shapes, colors, sizes, you name it. And even though it was not trained on any medical images, it does a good job. Go figure. But often that's called transfer learning, where it learned on ImageNet and now is used to classify an image. So basically, computers don't recognize images, they recognize numbers. So they understand pixels. And in the case of white or grayscale, black is 0 pixels, as you can see over here, 0. And let me increase that. Can you all see that okay?
Yes.
Doesn't need to be any bigger. I can make it bigger. Maybe that's a little better. So the black is 0. The white can be as high as 258 and everything in between. So first of all, for the grayscale, that's what it looks like. For color, it's red, green, blue, and that means it's in 3 dimensions or 3 channels. We're not going to worry about color right now. But let me, again, go back and forth a little bit. That the whole thing you need to understand is the convolutional neural network has multiple hidden layers, multiple ones. The purpose of that primarily, though, is to deconstruct the image into something more manageable that's smaller and doesn't require as much computation. And then it classifies it. What is it? Is it a car, a truck, or a van? So we'll talk about those steps in sort of brief terms. But what you need to understand is it will go through the same evolution of convolution, ReLU, which is activation followed by pooling. I'm hearing reverb. Are you all hearing that?
No.
Okay, hopefully it's not my own reverb. That's entirely possible. And in terms of hidden layers, it could be 100 hidden layers. The Google CNN that is available to you in orange is 48 layers. The little one, SqueezeNet, is only 18 layers, but each layer does something different. It may look at a different part of the image, but you might say, well, what's a convolution? That is also called a filter or kernel, where it goes back over here, and it could be 3 by 3, 2 by 2, 4 by 4. It goes over this, let's say 3 by 3. It calculates what it wants out of that, sends those numbers, adds them up, sums them, and sends it forward, and goes through it stepwise fashion over and over again. So the kernel, the developers can set the size of the kernel, whether it's 2 by 2, 3 by 3, 4 by 4, whatever. The smaller, the better, but it's slower. So they set that. The stride is something of, does it go 1 block at a time, 2 at a time, 3 at a time? And so that's all you really need to know is the developer can set the kernel size and the stride. So let's talk about these layers in a little bit more detail, but honestly, I don't want to go into it. If you look at some of the online educational materials, they may end up making you more confused than not, unfortunately. So again, you start with an image that's now in pixels that the convolutional neural network can filter backwards and forwards to get scores, if you will, and send it forward. And again, there's going to be multiple layers, each doing something a little bit different. Now, let me explain the activation layer, because every time you have a convolutional layer, it goes through an activation layer. Here's the what you need to know is if it didn't have an activation layer, it would be a lot like linear regression. It would just pass these coefficients or relationships, and it would calculate something based on that. But an image is not linear. It's a non-linear function when you try to analyze it. So what happens is, this is the most common one. ReLU is rectified linear activation function. What it does is it will pass, and I'll just show you on the right, if the number that's calculated is minus, it'll be passed forward as 0 or not at all. Whereas if it's +2, it'll be passed as +2. This is like a threshold or filter, but this is the only way you can handle non-linear relationships. That's the whole point. So that's the activation layer. Then the third layer, pooling layer, is more of the same, of trying to squeeze all the information out of the image as possible. This is max pooling. Notice over here, so you see the pinkish looking, whatever you want to call it, matrix here. The highest number is 6, so it goes to 6. Highest one in the green is 8, goes to 8. So that then gets passed on through an activation layer to the next layer. That's just a way of simplifying this image into the smallest computational entity it can. That's really what it amounts to be. So that's two-dimensional, if you will. And then to add to the confusion a little bit, and I'll go back up a little bit, it goes to a fully connected layer where every neuron is connected to another every other neuron, and then a flattened layer means that it's one-dimensional. It's like this really long column of numbers. And then softmax is a classifier like logistic regression, and it gives you the probability. Let me scroll down and show you that. So here's, again, when you come up with these small bodies of numbers, sort of a nugget out of that image, that's called a feature map. And then this is the flattened layer. It's one-dimensional, one long column. Then here is softmax, which attempts to calculate the probabilities, again, like logistic regression. So instead of giving you 1 and 0, car, yes, 1, not car, 0, it gives you probabilities instead. And that's really the whole idea behind it, is, again, getting back up here, think of it as two major phases: deconstruction into its simplest, numerical form, and then because it's already trained ahead of time on everything imaginable, so it's not training on cars, and it recognizes images, shapes, and so forth, and then it's classified into what it is. And again, there are other kinds of activation layers. I won't talk about. There's other classifiers besides softmax, but softmax is probably the most common. So again, you could classify any image into something, if you will. All right. I think that's enough. I did comment that when we use Orange, Google Inception version 3, like some of the others, is server-based. So it, to my knowledge, it's on the server in Slovenia. You're not, or somewhere. Whereas SqueezeNet, let's see where the SqueezeNet must be down. Yeah, SqueezeNet is smaller with 18 layers. That's on your computer somewhere or in the orange package. So it stands to reason that it's faster, but it probably not quite as accurate. All right, well, let's go ahead then and let's bring up some orange. I need to see which one is which. Yeah, here we go. So here we're going to look at images of melanoma versus benign keratosis, which is, something that pathologists have to face. In other words, differentiating between the two. I used a large data set that I think I gave you all. I think it's ISIC. So there, in the training data set, there's 2,998 images, half of which are benign keratosis and half are melanoma. And that's what you're going to train on. So basically, then I also took some of those into a test data set, only 42, which is really too low, too small. But notice the image viewer. I want to make an important point here. So you have a ton of benign keratosis and a ton of melanomas. But one of the things you have to be sure of is the image quality. And not only the quality, but things like the background. Let me cite a very important case, I think, for the military, is they were using an early convolutional neural network to identify enemy tanks. And they said, my God, it's perfect. There are no false negatives, no false positives. It's perfect. And someone later realized that the enemy tanks all had a different background than the US tanks. It wasn't recognizing the tank, it was recognizing the background. So the quality of the image you have to be a little bit careful about. I can't absolutely vouch for these. This is an international data set. You notice the melanomas are different size, different color, typically irregular, which is one of the ABCs of melanomas. But the point is, if, for instance, all melanomas had a pink background and all benign keratoses had a white background, it's going to learn the background. So just be aware of that. That's the beauty of looking at the image viewer. And we'll look at the colon cancer here in a minute. All right, so all you do, by the way, is you upload a dual folder. It's going to be two folders, one melanoma. So you have a master folder, call it dermatology. In that master folder are two subfolders. One's melanoma, one's benign keratosis. Does that make sense? So that's trained. It knows to look at all of that. So then you connect it to image embedding. Again, to save time, I use SqueezeNet. It's just, faster than the bigger one. But again, the result's not as good. So we're going to try to, again, classify this into either melanoma or benign keratosis using 3 algorithms. Now, I've not tweaked. This is just 100 neurons in one hidden layer, which is a bit odd, but you can do that. You can set any number of layers you want and any number of neurons per layer if you want. Uses ReLU again, Atom Optimizer, and you could set regularization low or high. So those are your options. I chose not to do anything with them. And then what you really want to do primarily is look at the test results. Now, I'll caution you, these results are too good to be believed. And I think that's simply because it's a small data set. In other words, the training data set was good, but notice recall is perfect. one of the best ways to look at this is look at the confusion matrix. Let's take gradient boosting. So it predicted melanoma, and it was melanoma 21 times. However, it predicted melanoma, and it was not melanoma 14. That's a lot of false positives, but it didn't have any false negatives. So that gives you an idea. But what you could do is you could highlight this if you're the pathologist and send it here and start trying to figure out what's going on. Is it the background color? What's deceiving about it? Again, I have not looked at this. I can't tell you, the reasons why. To me, this looks like a melanoma. So does this one. So it's not easy. But my point is, this is a really kind of a cool way, whether you're looking at derm images or EKGs or chest X-rays or whatever. And I meant to mention something and I overlooked it, and that is Orange does this beautifully, but there's two other free convolutional neural networks available to you. One of them is Microsoft Loeb, that's probably 6 years old, still out there, still free, works great. It's same idea. You upload a dual folder, like I talked about, and it gives you the same information. I like this better because this is more transparent. And then the third one is Google Teachable Machine. And I don't have a lot of experience with it, but those are 3 convolutional neural networks that are available to you free if you have a project that you're interested in. So let me go then to the colon cancer. And what I like about this is I think, and let me try to blow this up a little bit. I actually didn't accomplish what I wanted. Now, wait a minute. So unfortunately, you can't see these in detail. But the quality, I think, in terms of the H&E staining is very uniform. So I think that the quality of the specimens that I looked at, I thought was very good. And I apologize, I don't remember where I got that. If you need that for some reason, I can try to look longer and harder. But so the whole idea here, and because there weren't many, there are only 100 images, so 50 of colon cancer, 50 of a normal colon mucosal biopsy. I opted just to do training and not split it, to do train and test. So what you're going to see here is simply the results of the training. And then once again, I use SqueezeNet, and I use the same 3 classifiers. We'll see how well it did. Again, really too good to be believed. Probably, again, because it's a small data set, probably should be 1,000 images to be even better. So here's the confusion matrix. Let's look at logistic regression. Again, it predicted colon cancer, and it was colon cancer, 50 out of 50. It was negative, predicted negative, and was negative 48. So that's your true negative. So there was 1 false positive only and no false negatives. So it did incredibly well, I might add, but that's in the training data, and that's pretty small. So bear that in mind always. And so let's do the same thing we did before. Let's select the 2 false positives and look here. And again, these would have to be blown up. They are numbered. You could go back and try to figure out why why it labeled these as cancer. I can't answer that. So let me stop there. That's all I was going to go over in terms of image analytics. What's changed is when convolutional neural networks came out 15 years ago, it was all about taking several thousand images, training a convolutional neural network, and then doing what we just did. with the advent of generative AI and different mechanisms like diffusion and whatnot, it does a pretty good job of guessing without specific zero shot, basically training, as opposed to training on thousands of images. So that's how times have changed. But I think you still should know about this because this is certainly something that's very transparent. You can see exactly what you did. Whereas generative AI, sometimes you don't know exactly what happened. Now, let me stop with that. Any questions on using Orange to look at these images?
So
Okay.
the tile that is says image and embedding.
Yep.
Why did we have to do that? Use that tile? What does it do?
Okay. Image embedding is the convolutional neural network.
Okay, so that's it. Okay.
Yeah, I'm sorry. I should have stressed that. So, in other words, embedding, the word encoding means you're converting something to a number.
Right.
Embedding means you're converting it to a basically a matrix or a vector.
Okay.
And, you know, so you can then measure things, if you will. So in this case, it's really taking the pixels in this colon cancer biopsy image and going through all the steps of the convolutional neural network that I described.
Okay.
So that's the embedding process, and I should have made that clear. So that's SqueezeNet convolutional neural network that's on your computer somewhere is going over that image and basically breaking it down with the convolutions, the activation layer, and the pooling layer, and then your classifiers are trying to classify it. What is it? Does that make more sense?
Yes, sir.
Okay, very good. All right, so next I'm going to go over geolocation, but again, I didn't want to go over it in tremendous detail. It may be something you don't use, but I thought that it was nice in terms of how easy it is in Orange. Sometimes with public health data, you'll have latitude and longitude. And there may be times when you have, geez, I'd love to see the distribution of that. So here's the Seattle housing data. And I skipped some of the things in here. And notice there's one categorical feature. We converted that to numerical. So there is the housing data set. So it has lat longitude. Here again, we converted waterfront into numerical, and that's where the encoding comes into handy. And the geocoding widget, all you're doing is setting latitude and longitude and state here. That's it. And you're selecting decode. And the end result of Seattle here, and let me go back actually. Because that's not the whole story. You then will select price. You could select other things like whether it's waterfront, for instance. So this is selecting the price of houses. So you notice over here in this legend in the lower right, again, probably old data. Seattle's probably nothing's left in 500,000. But the point is the darker blue towards the water makes sense, is more expensive than lighter colors, which maybe is in areas, who knows why, less desirable. So I think that's helpful if you're trying to study some kind of trend and you have lat longs, uh, then that's one way to do it. And this one, I did it, it's less meaningful. This is COVID deaths in the state of Alabama, if you will. And so let's look at that same setting on the widget. And in this, I'm not sure I totally believe it. Let's go back and look at what we set. We set depths, latitude, longitude. It uses OpenStreetMap. And my only comment, it looks again a little too neat. Meaning, let's look at it again. These points look to me to be equidistant.
Yeah.
I don't quite know what that means. So this is just an educational example, but by no means do I think this is very helpful or whatever. But it's just that when you have a data set that has latitude and longitude, you can start seeing the distribution of something like an outbreak or whatever you're interested in. Does that make sense?
Yep.
Okay. I wasn't going to spend any more time. I did think in the time remaining, I wanted to talk about sort of a project that I'm doing. I have two projects with large language models, specifically with DeepSeek. How many of you all have used DeepSeek to any substantial degree?
I'm using.
Okay. I'm really impressed, and I'm not impressed easily. I really think that it does reason. Anthony Chang thinks it's just parroting stuff, but I think it's actually reasoning. So there's two projects out there that I'm trying to duplicate. One of them, let's see. Let me see if I can find. Yeah, here we go. So one of these projects, just trying to move things out of the way so I can see, created a new MedQA. You know, the MedQA is like USMLE standard medical questions. But what they did is, so they kept some of the questions original. And then they removed the answer, the correct answer for these number, whatever number that is. Then they modified the question among these. And then they had some bad questions that were, you know, for instance, they may have removed an image, ask what does this image show, and then remove the image. And then these fictitious questions all had to do with a fictitious organ called the Clinorex organ. So the point I want to make is that the large language models, and they tested 11 of them, did okay here. The scores of like 70 to 80%. But down here, they scored more like 3%, and that was the best. And that article was called Large Language Models Lack Essential Metacognition, meaning they were easy to fool if you change the answers. So I've started doing that and looking at it in my results. And again, I've only gotten a certain amount. For O3 Mini was 70%. And for DeepSeek, it was 80%. So that's that project, but I'm doing it manually, not by programming, so it's slow. The second project, let's see if I can find it, is MLLU, which is, let's see, Massive Multi-Language, Multitask Language Understanding. So that's a project of like 14,000 questions in multiple domains. So these people modified it and published it recently. And what they did is they added more complex questions, but instead of 4 answers, they're usually 10 answers. And so this was more difficult. For an overall score, they have already reported DeepSeek R1 scored 84, which is higher than any of the others, but there's no record of how it did on health data. So you can dial up health data, and then you can separate it into multiple subcategories. That's not it. Let me find it. Here it is. Multiple subcategories. This is called professional medicine. What that means is these are scenarios that are pretty tough. People, you know, all ages and all kinds of difficulty, if you will. And again, tend to be 10 plausible answers. So what I wanted to know is how did this time I'm only looking at DeepSeek, just because my experience is it lists the reasoning steps in way more detail than O3 Mini. It's really made a believer in me that it really is reasoning. So here's the results, and it's kind of interesting. I only did 25 people so far, 25 questions so far. It missed 3. However, this one it missed, I went, wait a minute. I had 3 physicians look at it blind, and they answered, and they said, yeah, they gave me the answer, and that's not. So they said what the model said was right was right. There's another one here that I think is, notice the 0. I think it's a bad question. I think the answer is screwed up in terms of typos and stuff. And then the last one, that's an error. Here, I haven't had time to check it. I was looking at this today. But so this is a project where I want to look at 100 or 200 because my suspicion is the highest model for health data is around 78%. I think DeepSeek is going to do better than that. But the other thing I want to throw out there is the fact that some of these MedQA questions are probably wrong. And number 2, I'm starting to see DeepSeek go out on its own and say, hey, where's the ketone level? I need the ketones. Or why didn't you consider infection in a drug abuser? I mean, it is going into way more detail on some of these medical questions. So let me stop with that. I just personally, I find that very interesting than just pure root memorization, which is what has occurred mainly with MedQA questions. Comments by you all, what do you think?
It's funny because I was doing the same thing on ChatGPT 4o for the board questions. Some of them are not being used, some of them are being in circulation, and some of them are being written. And you're right. ChatGPT 4o is good. It will pass between high 70s and mid 80s. And of course, I'm not willing to put the questions on the DeepSeek because they are still board questions, and unless you make sure that on my side of the firewall, I cannot be putting those questions out.
Yeah, yeah. Well, and again, there's also, I've realized, a giant question about DeepSeek, but the very fact that Microsoft is using it, the very fact that Perplexity has both DeepSeek and O3 Mini, says to me they're fairly confident that behind their firewall, there's not going to be any kind of leakage of data or any interference or hacking or whatever. So I'm going to continue to test it. But if you have not used it, I strongly recommend it. I'd be more than happy. Did I understand that everybody has used it? Yes or no? I'm going to take that as a maybe.
Yes.
So here is Perplexity, which I used. I found that to be as fast, but I want to just demonstrate. So this is one of these questions I was talking about. So before it answers, it looked at 35 sources. And then what's nice, and this is, I again, run by you, how can we mine this better? M-I-N-E. How can we mine it better? These are the steps, and each one of these can be broken down. To me, we should be able to prove what it's doing with that amount of information. We should be able to say exactly what it's doing. I'm sure there's somebody out there doing that, but I think there's good demonstration that it is taking in information and then organizing. So notice after getting all these references, says, okay, let's tackle this question. And so it goes over the camping trip. This patient has some kind of bizarre infectious disease. I think it was Rocky Mountain spotted fever, actually, if I remember right. But it goes through it, but it will go back over it and say, wait a minute, I think I'm wrong. notice this says, however, the rash is usually petechial and starts on extremities. So I just want to demonstrate that it rethinks things. It's iterative. I had no
Yeah,
idea Star was
yeah,
referencing.
and in the Chat GPT Scholar, when you run these things, it goes through why is answer A is correct for it and why answer B is incorrect for it, and then of course always make sure that say please provide the references because sometimes you'll find out that it's making up stories.
Yeah, I mean that's true, and I have to say that I've seen that trend decrease with the newest ones. But to your point, in all fairness, did I go back over each one of these and verify? No, I didn't. But again, generally, if you look at just the title, necrotizing soft tissue guidelines, those look pretty solid to me. Uh, so anyway, but my point is, I think this is the most transparent and in-depth reasoning I've ever seen from a model. I mean, 4.0 does do well. As you said, I think with a little bit of some type of special prompting, it scored up around 90% on the MedQA questions, which is really good. But they've been criticized for several reasons that's not the same as a scenario necessarily, particularly a longer scenario. But I think that this is just interesting. Notice it says another angle. And here's another one. If the correct answer is doxycycline, the target would be blah, blah, blah. So it's making all kinds of associations and observations. It's a little repetitive. Sometimes it'll repeat the same thing more than once, which I'm seeing that. But anyway, I just thought that, it's worth showing. And also, y'all are probably aware that let me move things. There we go. That Perplexity now has deep research to compete with deep research by Google, deep research by OpenAI. There's even open deep research, which is not online yet, will be an open source deep research. So there's lots of them out there, and that raises a whole different question is, what's the legitimate use of those? I think they're legitimate to research something. I don't think they're legitimate to write it. I think there's a huge difference. But again, to me, I find them very helpful, but you do have to check all the resources to be sure they're legitimate. Any questions about that? I just wanted as a little bit of show and tell. I hope to get enough to publish something here in another month, perhaps, but I just thought it's interesting to be looking at these reasoning models. Okay. Again, this is recorded. I will share it with everybody. Next week, Aaron will go over again Google Colab, how to use it, sort of some practical pointers. Should you need to copy and paste code, Colab is probably your best bet, easier than, say, Jupyter Notebook. And then again, I'll go over more detail about how to use Gemini with Google Sheets and how to use Visly for data analytics. Any other, oh, by the way, questions before we close this session? I do, look forward to any critiques, positive or negative, for the website, aianalytics.pro, because it's a work in progress and it's there intended for general education. Oh, one other thing I did, by the way, and I got this from another paper, is I asked the model, what's your confidence level? and notice that the confidence level was 4 3 times, the rest were 5. So it's very confident. All right. Any other comments?
Dr. Hoyt, I just have one question. Like you showed like a visual in your website, which showed like which was made by a AI's website. Could you please repeat that name for me? I couldn't catch
Yeah.
it. Which one?
Hostinger. Let me put it in.
Not the hosting.
Yeah, I'll put it
the
in
graphic.
the.
Yeah.
It's funny. I'm used to having it say everyone, but let me see.
Okay,
So you
thank
see
you.
here. But again, the cost, by the way, for 4 years was $150.
Yeah,
I was
that's
paying more
good.
like $300 a year for my Wix sites,
Yeah.
and had things I didn't really need. I did not need a special email. So this ended up being simpler, faster, just as intuitive, if not more intuitive. So I'm not here to sell you on Hostinger, but just to
I was
say,
curious. Yeah.
you know, again, people sometimes want to create their own personal website or whatever. So I do recommend it without a doubt. It was very good. Okay. Well, I appreciate your attendance today. And
Bob, can I ask a question? This is
yeah,
Faisal Said. Thanks for a great session. So, are there options in Orange to do other forms of um, machine learning apart from CNN, other models, or is CNN the main
you
um,
mean
deep learning
for
model?
vision analytics specifically or computer
Yeah,
vision? Yeah,
yeah.
no, it's strictly CNNs and it gives you a choice of 5. Yeah, that's it basically. They don't do anything further, and I think that's largely because it's been replaced by generative AI.
Okay. Thank you. This was a great session. Really enjoyed it again.
Well,
Thanks.
good, yeah, and do email me if you think of a question later on. But look forward to seeing you all in a week. All right, take care.
Thank you.
Thank you.
Bye bye.